Hello students, in this video we will be seeing the transmission media. The transmission medium is the physical layer or virtual path by which a message travels from sender to receiver. In this picture we can see the sender is sending a message through physical layer over the transmission medium. The transmission medium, either it may be a cable or it may be a air medium, and the receiver receiving the message through the same physical layer, which you have already seen in the OSI model. Mainly, the transmission media is divided into two types. The one is guided media, the other one is unguided media. In guided media, there will be a physical path provided between the connecting devices. There are three types of guided media available so far. The one is twisted pair cable, the second one is coaxial cable, the third one is fiber optic cable. In unguided media, air is considered as the only transmission medium. That is, the free space is considered as the only transmission medium. The first type in the guided medium is a twisted pair cable. A twisted pair cabling is a type of wiring in which two conductors of the single circuit are twisted together for the purposes of improving electromagnetic capability. So in this picture you can see there are two different conductors available, which is coated with an insulator. Insulator is nothing but a plastic or a polythene material. Normally we can see these kind of wires laid in our laboratories, which is used to connect the systems. There are two different types of twisted pair cables. The first one is unshielded twisted pair and the second one is shielded twisted pair cable. In the picture you can see there is a plastic cover covering the inner twisted cables, which is called as unshielded twisted pair cable. Whereas this shielded twisted pair cable will have a metal shield covering the inner windings of wires, and which will also be covered by a plastic cover like a unshielded twisted pair cable. Based on the applications, the twisted pair cable is categorized into 7 types. The first one is unshielded twisted pair, which is used in telephone lines, and which will be having the data rate less than 0.1 Mbps. The second one is unshielded twisted pair, originally used in telephone lines, and it was advanced over the first category. The third one is improved Cat2, which is used in LANs, and the data rate for that one is less than 10 Mbps. The fourth category is improved Cat3, which is used in token ring network with the data rate less than 20 Mbps. And the fifth one is the cable wire, which is normally 24 AWG with a jacket and outer shield. And this was having the data rate of 100 Mbps. And after that, they have made some advancements over the fifth category, and they called it as an extension of a category 5, which includes extra features to minimize the crosstalk and electromagnetic interferences, and they have achieved a transmission rate of 125 Mbps. The next one is new category, that is sixth category, with the matched components coming from the same manufacturer. The seventh category is also called as shielded screen twisted pair, where each pair is individually wrapped in a helical metallic foil followed by a metallic foil shield in addition to the outside shield. The shield decreases the effect of crosstalk and increases the data rate. And the final data rate they have achieved is 600 Mbps, which is commonly used in LANs now. As we have seen what is twisted pair cable in the previous slides, in this slide we will be seeing the UTP connectors, that is unshielded twisted pair cable connectors. These connectors are normally called as RJ45 connectors, and there are two different connectors available, which is one is called as female connector, the other one is male connectors. In this picture we can see a RJ45 female connector, which is available in all the laptops and even desktops. The second type of transmission medium is a coaxial cable. A coaxial cable is a type of electrical cable consisting of an inner conductor surrounded by a concentric conducting shield with the two separated by a dielectric or an insulating material. In this picture we can see there are four different parts of a coaxial cable. The outer part is called as plastic cover. The second part will be having an insulator, and inner to that we will be having an outer conductor, or a shield which is made up of a mesh of wires, and there will be an inner part which is normally used to transfer the data from one place to other place, which is called as a inner conductor. Here we are seeing the categories of coaxial cable. The categories are named as RG, which is nothing but the radio guide. There are three different categories available in the market. The first one is RG59, which is commonly used for a cable television. The second category is RG58, which is used in thin Ethernet, whereas the third category is RG11, which is used in the thick Ethernet applications. The BNC connector, or the bayonet nail concealment connector, is a miniature quick connect or a disconnect radio frequency connector which is used for the coaxial cables. Before proceeding with the third transmission media type, we are going to see the basic properties of light. The basic properties involves reflection and refraction. Reflection means a change in direction of waves where they bounce off a barrier, whereas refraction of waves involves a change in the direction of waves as they pass from one medium to the another one. So this is the basic principle which is applied in fiber optic cable. Optical fiber cable or fiber optic cable is a cable which is consisting of one or more thin flexible fibers with a glass core through which a light signal, normally a laser light signals, can be sent with a very little loss of strength. Set of data in the form of bits are converted as light signals and which is sent as a laser beam from the sender side to the receiver side. The laser light will be traveling over the fiber optic cable, that is inner core of the fiber optic cable, which will be following the principles of reflection and refraction. We can normally witness the post which is holding the name of OFC in the roadsides, which is nothing but the fiber optic cable which is buried under the ground, used for telephone communications as well as data communications. These fiber optic cables will work in two different modes. The first mode is multi-mode, the second mode is single mode. We will be seeing the modes in the next slide. In general, single mode fiber is used for long distances or a higher bandwidth needs, and it uses a single laser light as its light source, whereas the multimode fiber uses an LED as its light source and which is used for shorter distances or lesser bandwidth intensive applications. Fiber optic cables are constructed in a highly safety and secured manner. They will be having an outer jacket which is made of a thick plastic, and to inner which they will be having a dew point Kevlar for a higher strength, and inside to that there will be a plastic buffer, and innermost layer is nothing but the cladding which is made up of a glass or a plastic core. Why the glass is used here is through which only the laser light is being transferred, and the glass will be helping the laser light to get reflected and refracted to reach the destination. Like the other transmission mediums we have seen, here also there will be a connectors which is used to connect both the ends. So there are three types of connectors used here. The one is SE connector, ST connector, MTRJ connectors. Now we are going to discuss the second portion of the communication medium or the transmission medium, which is nothing but the unguided medium or a wireless medium. An unguided media transport electromagnetic waves without using a physical connectors, and this type of communication is often referred to as wireless communication. For this, there are three different sections we are going to discuss. The first one is radio waves, microwaves, and the infrared waves. This picture shows the electromagnetic spectrum along with their applications. So there are various frequencies available in this electromagnetic spectrum, which is categorized as extremely low frequency, radio waves, microwaves, infrared waves, ultraviolet waves, X-rays, and gamma rays. So as far as computer networks concerned, we will be using only three different waves here. The one is radio waves, microwaves, and infrared waves. Radio waves and microwaves will have the frequencies ranges from 3 kHz to 300 GHz, whereas infrared is ranging in between 300 GHz and 400 THz. The ground wave propagation is a method of radio wave propagation that uses the area between the surface of the Earth and the ionosphere for transmission. The ground wave can propagate a considerable distance over the Earth's surface, particularly in the low frequency and medium frequency portion of the radio spectrum. In radio communication, skywave or the skip refers to the propagation of radio waves reflected or refracted back towards Earth from the ionosphere, an electrically charged layer of the upper atmosphere. Line of sight is a type of propagation that can transmit and receive data only where transmit and receive stations are in view of each other without any sort of an obstacle between them. For example, FM radio, as we have seen in the previous slide, here we are seeing the band, range, propagation and their applications. Ground wave propagation requires very low frequency and low frequency bandwidths. And as we have already seen, the ranges is between 3 to 300 kHz. Whereas for skywave propagation, it uses middle frequency, high frequency and very high frequency. Whereas the line of sight which we use for the applications like cellular phones, satellite communications, they require ultra high frequency, super high frequency and extremely high frequency. Among these three different waves, radio wave alone is used for multicast communications such as radio and television and paging systems, whereas microwave alone is used for unicast communications such as cellular telephones, satellite networks and wireless LANs. And finally, infrared alone is used for short range communications in a closed area using a line of sight propagation. So normally in our mobile phones before Bluetooth, we had this one called as infrared for data transfer between the two devices. There are many different types of antennas used for this wireless communication. Few of them are isotropic antenna, dipole antenna, monopole antenna, array, loop antenna, conical antenna, aperture antenna, traveling wave antenna are the few commonly used types. Among these antennas, omnidirectional antennas were mostly used for radio wave communications. Antennas were considered to be a most important equipments for any wireless communications. An antenna is an interface between radio waves propagating through space and electric currents moving in metal conductors used with a transmitter or receiver. Unidirectional antenna focuses the radio frequency energy in one or two directions, which lowers the beam width and the overall area covered, but increases the strength of the signal and distance covered in that direction. Dish antennas or a parabolic antenna is an antenna that uses a parabolic reflector, a curved surface with the cross-sectional shape of a parabola. Fine, we have come to the end of this topic. We will see the next topic in the next video. Thank you.